So trig is something that you'll do a little bit here and then a lot, like a quarter of the year in pre-calculus is trigonometry. So this is just the basics that we're introducing you to so that you have some basic understanding. I'm hoping that this seems familiar to you from Algebra 1. I know if you had Mrs. Coors, you should have had some basic trig last year. I don't know, obviously about if you were not at Cathedral or didn't have Mrs. Coors, but typically the end of Algebra 1, you'll do a little bit of basic trig to kind of get you introduced to it. So first of all, the term trigonometry, which we call trig, means triangle measure. So the metry part is measure and trig refers to triangles. Okay, when we discuss trigonometric ratios, that's sine, cosine, and tangent. That might ring a bell, the SOHCAHTOA, if you remember doing that before. We are simply comparing the lengths of two sides of a right triangle. So maybe you're dividing a leg by the hypotenuse. Maybe you're dividing two legs. It's just simply a fraction that you get from a right triangle using one of the angles and two of the sides. So why trig is helpful? What you're trying to do is build a toolbox that you can use to solve problems. So in particular with right triangles, we already know things like the geometric mean theorems. We know that if it's a 45, 45, 90 or 30, 60, 90, there's ways to figure out side lengths without having to do the Pythagorean theorem, without having to know more information. We know the Pythagorean theorem and Pythagorean triples. So this is another tool to help you solve right triangles. Now, the thing is that it's actually a way to find angles and side lengths in right triangles that you cannot find other ways. So I could give you a right triangle with one angle measure and one side length, and you can use that to find the other two sides. So that's something you're not able to do right now. You don't know trig, and trig is the way you do that. Okay, you'll do this a lot more in depth in pre-calculus, but this is kind of the basics to make sure that it's either you've seen it or remind you of maybe what you did in Algebra 1. So there are three different trig ratios. They all have to do with right triangles. There is non-right triangle trig, which is something, again, you'll do in pre-calculus. I tried to do that with you guys in honors geometry, but because of the time factor, we may not do that. I'm not sure yet. It would be the last stuff that would be in chapter 8, but we'll have to see. I plan out a little bit further if we're going to get that in or not. So when you're doing trigonometry, you're looking at an acute angle of a right triangle. So here's a right triangle. The standard convention is that when you name an angle with a capital letter, the side across from it gets the same letter but lowercase. Okay, so notice how we've got capital Y is the vertex, across from it is lowercase y. So this is triangle XYZ. I want you to look at angle X. Okay, in relation to angle X, there are three sides: opposite, adjacent, and hypotenuse. Now, we know that hypotenuse is always the long side that's across from the right angle. So for sure, that's hypotenuse. Okay. And then there's one leg that's opposite from X. It's like across the triangle. It's not touching the vertex. That's the opposite leg. And then the leg that's beside the angle that's touching the vertex, here is called adjacent. Now, there's actually two sides of the triangle that are adjacent to X, but the hypotenuse is the hypotenuse. Okay, the hypotenuse is always determined by being across from the right angle. So you're never going to call the hypotenuse the adjacent. When you talk about opposite and adjacent, it's always referring to the legs. Okay, the hypotenuse already has a label. It's the hypotenuse. Okay, sine. You read this. So this is the long name for it, and this is the abbreviation. It's obviously not much shorter, but the standard convention is to make all of these have three letters: sine, cosine, and tangent. But when you read them like sine, cosine, and tangent. Okay, you can say tan, but you don't really say cos or cos. You say cosine and you say sine. This is not sin, this is sine. So that's how the actual name is written. This is the abbreviation, but you still read it like sine, long I. Okay, the definition of the sine of an angle is the length of a side that's opposite from the angle divided by the hypotenuse. So sine is opposite over hypotenuse. For angle X, the opposite is the little x and the hypotenuse is the little z. Okay, we're doing opposite divided by hypotenuse, little x over little z. Now cosine. Cosine is defined to be the adjacent divided by the hypotenuse. The adjacent here is y, the hypotenuse is z. So the cosine of capital X will be little y over little z, adjacent over hypotenuse. Okay, and then the tangent of angle X, the definition is opposite divided by adjacent. So the tangent of angle X will be little x over little y. Opposite over adjacent. Now, it doesn't matter how big or small the triangle is. If a triangle, like for example here, if a triangle has a 35-degree angle in it, the ratio, if we were to do, for example, sine, okay, the sine of angle 35 would be the ratio of the opposite leg divided by the hypotenuse. In the other triangle, the sine of 35 degrees would be the ratio of the opposite divided by the hypotenuse. Okay, those triangles are similar. That means that their sides are proportional. So this ratio is the same as this ratio. That's why the sine of 35 is a fixed number. It doesn't change with how big or small the triangle is. Okay, the sine of 35 means in a right triangle, the 35-degree angle's ratio of the opposite leg over the hypotenuse is always going to be the same value. And it's, you know, whatever that number is. So because the triangles are similar, that means that we're always going to get the same value if you use cosine of 35 degrees or whatever. Okay, so I think I sent this to you in a remind, but you need to have a calculator. By the time we're getting down to the problems down here, you're really going to need a calculator to work out those problems. If you don't have a handheld calculator, you can do this on a calculator app for now, but when you do your homework, you need to, in the review and in class next time I see you, you need to have a handheld calculator, whether it's a graphing calculator or a scientific one. That means it'll do like square roots and squaring, and it's not just like plus, minus, divide, and addition, subtraction, multiplication, division. It has more than just the for function. It's a scientific one that will do more things than just the basic for, I would say properties, calculations. So if you don't have a handheld right now, you got to make sure you get one and you want to use it. You want to practice using it on your homework and in class and on the review for the test, because obviously you can't use a calculator app on the test. So I want to make sure that you're comfortable with the calculator that you're using. All right, so let's start. First, it's saying sine A, B, sine, cosine, and tangent of angle A. Now here is a mnemonic device that we will use to help us remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, when you read this, you should be thinking sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Sine is opposite over hypotenuse. Oops, sorry. Hypotenuse. Cosine's adjacent over hypotenuse. And tangent is opposite over adjacent. Now you're going to see these with actual numbers now. Okay, so see how you have a 9, 12, and 15 on that triangle. Let's start with angle A. So in relation to where angle A is, I want to label the opposite, adjacent, and hypotenuse. Bronson, where's the hypotenuse?
It would be 15 because it's across from the right angle.
Okay. So the hypotenuse,
AB.
yeah, the hypotenuse is always the easiest side to find because you always go across from the right angle. Okay, it's always the longest side, it's always across from the right angle. Then in relation to angle A, across, you have which side? Brooke, where would be the opposite? Where would be the adjacent? What is the 12?
12 is opposite and 9 is adjacent.
9's adjacent. And again, adjacent means the leg that's adjacent to the angle. The hypotenuse is also adjacent, but it can't be adjacent because it's the hypotenuse. Adjacent and opposite are legs. Hypotenuse is the one across the right angle. Okay, so sine. Sine is opposite over hypotenuse. So in the triangle, when you look at angle A, the opposite divided by the hypotenuse is 12 over 15. Meg, what is that simplified?
4/5.
Divide out of 3, 4 over 5. Okay, cosine. Adjacent over hypotenuse. Okay,
I said 4/5, not 4/3.
good.
If you divide it by 3, it should be 5, I thought.
Yeah, you did. You're right. Sorry.
Sorry.
No, you're good. I'm sorry. Okay, cosine A and not A. We're doing cosine, which is adjacent over hypotenuse. What's that ratio?
It'd be 9/15.
And then reduced would be what?
3/5.
3/5. Okay, take out a 3 over 5. All right, and then for our tangent, tangent doesn't use the hypotenuse. Tangent is opposite over adjacent. So tangent is going to be the opposite over the adjacent, which will be 12 over 9. Okay, take out a 3, 4 over 3. Now, rather than having to like write the ratio and then simplify each time, it might be a little easier if we just look at these original numbers. If you caught at the time when I said it's a 9, 12, 15 triangle, what can we do with 9, 12, and 15? When we started the problem, what would be a good way to start?
Just divide them all by 3.
Okay, Sam, why does it make sense to divide them all by 3?
Because the triangle is still going to be like similar, but it just makes the simplifying easier so you don't have to do it for each one.
Right, so when you divide by 3, notice that your side lengths are going to be 3 and what? You're going to have
4 and 5.
4 and 5. So instead of, the way that we had to simplify it every time right here, we can just actually go ahead and simplify it down because all we're doing is taking the triangle and shrinking it down proportionally by a factor of 3, and the ratios will be the same because the triangles are similar. Okay, so it doesn't matter if you actually simplify kind of like the triangle size at the beginning or if you simplify your fractions as you go. So it's a little quicker now. We can just kind of look, instead of using the 9, 12, and 15, let's go ahead and use the 3, 4, and 5. So let's use 3, 4, and 5 here. So the sine of B. When you go to do the sine of B, so now we're standing on B, what has changed? Has the hypotenuse changed? Has the opposite changed? Has the adjacent changed? Have all of them changed? What do I need to change now? Because when I jump over to B, I now have a different perspective. What changes?
The adjacent and the opposite.
The adjacent and the opposite. Thanks, Riley. So the opposite and the adjacent are going to swap. The hypotenuse doesn't move, right? It's still the side across the right angle, but it doesn't make sense to call that the adjacent now because now we're sitting at B instead of at A. So our perspective changed, which means this is now the opposite leg And this is now the adjacent leg because the legs positions are relative to the vertex that you're, or the angle that you're using. Okay, so it's all about your perspective. So it's still sine is opposite over hypotenuse. Okay, so sine of B is opposite over hypotenuse. Opposite over hypotenuse is going to be, for angle B, 3/5. And again, notice that we don't have to simplify this time because we already have it broken down. Frankie, what's the cosine of B?
Be 9/15, or right?
That would be the
Or be
sine.
opposite over
Okay, I asked you.
hypotenuse. Wait, no. Oh wait, it's adjacent. Okay, sorry. Yeah, so 12/15.
Have you ignored me the last 5 minutes while we were?
4/5.
Okay, so since we simplified that down, we don't need to use the 12 and the 15. We can just.
Yeah.
Okay, so adjacent over hypotenuse means 4/5.
Yeah.
And then Allison, can you give me the tangent?
It would be 3/4.
Over 4, opposite over adjacent. Now, I would like you to look at those numbers and tell me if you notice anything. I would like to hear from someone who has not answered a question yet today.
Wouldn't it be a Pythag triple?
Okay, so yes, 3, 4, 5 is a Pythagorean triple. That's true. I would like to know something that you observe about the numbers over here compared to the numbers over here.
They're reciprocals.
Are all of them reciprocals?
No, like the tan part is.
Yes, good. Okay. So one thing that you should notice is that the tangents are reciprocals of each other. Okay, someone else. What is something else you notice?
The sine of one of the angles is the same as the cosine of the other one.
Good. So notice that the sine of A and the cosine of B are the same. And the cosine of A and the sine of B are the same. Now, why is it working like this? So Scott, can you explain, does it make sense to you why the sine of A is the same as the cosine of B? So we got 4/5 for both of those. Can you explain why that's happening?
Because the opposite and adjacent sides of each of the angles are switching,
Right,
and they're both over the hypotenuse.
right.
So you get the same answers.
Yep. Okay. So over here, I didn't write this initially. So let me come over here and write this. Where sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. I'm sorry, I used A there twice. I should have named those something different. Tangent is opposite over adjacent. So when you're comparing the opposite to the hypotenuse from angle A, the opposite is the 4. Okay. But when you do the cosine from angle B, cosine's adjacent and the adjacent is 4. So they're both using the hypotenuse of 5. But because the opposite and the adjacent swapped, that means that the sine of one angle is the cosine of the other one. Now, how would those angles be related to each other if this is a right triangle? So in the right triangle, how are the right triangle? How are these angles related to each other?
They're complementary.
Complementary. So that's because all the angles add to 180, right? You take out the 90 for the right angle, the leftovers have to add up to 90. So in a right triangle, the sine of an angle is the same as the cosine of the angle's complement. All that's saying is that the sine of A is the same as the cosine of B, and the cosine of A is the same as the sine of B. Now, someone I haven't talked to today, tell me why it makes sense that the tangents are reciprocals. Why are the tangents reciprocals?
Because we're not using the hypotenuse, and so it's just the opposite and the adjacent.
Yeah, you're not using the hypotenuse, right? So that means when you switch your opposite and your adjacent, it just takes the fraction and it flips it over. Good. Okay, so noticing that relationship can help you. If it gives you a right triangle, says find all the sine, cosines, and tangents, for the whole triangle, you can do one of them. Just be really careful with the one column, and then you can just transfer it over the other one. All right, here's a triangle. Notice that that's going to be a 30, 60, 90. So this is a special right triangle here. So they've given you that 30, they've given you that 30-degree angle. So that one's 30, meaning this one has to be a 60. So this is a 30, 60, 90 triangle. Okay, now in a 30, 60, 90, what is the kind of simplified ratio for the side lengths? If I make this short leg a 1, what can I put on the long leg and the hypotenuse? So 30, 60, 90. If the short leg is 1, what goes on the long leg and the hypotenuse?
The long leg has root 3 and the hypotenuse has 2.
Root 3 and the hypotenuse is 2. Okay, now from in the table here, it's saying, all right, let's start with angle M. I'm going to label the sides in relation to angle M. Let's label the adjacent, opposite, and hypotenuse. So Peter Gruber, can you tell me where the hypotenuse is?
Oh, sorry, I was on mute. It'd be 2.
Okay. And then in relation to angle M, where is the opposite side?
It'd be 1.
1 is the opposite. And then that makes this the adjacent. And again, remember, adjacent's always a leg. The hypotenuse is always the hypotenuse. So the adjacent's always a leg. Okay, so we're going to do sine, cosine, and tangent from angle M. And again, let me remind you that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So from angle M, sine is opposite over hypotenuse. Henry, tell me what the sine of angle M will be.
Sine of angle M would be 2 because it's hypotenuse over opposite.
It's opposite over hypotenuse.
Oh, so it'd be 1/2 then.
Okay, what about cosine?
That would be root 3 over 2.
Cosine is adjacent over hypotenuse, square root of 3 over 2. Does that need to be simplified?
No, because 2 is a rational number.
Okay, and then for tangent of angle M, tangent's opposite over adjacent, so what would that be?
1 over root 3.
Does that need to be simplified?
Yes.
So we'll simplify that, rationalize root 3 over root 3. Henry, what will that be?
That would be root 3 over 3.
3/3. So those are the exact values. Okay, I asked you for simplified radicals. Those are the exact values. Now remember that angle M is actually 30 degrees. So this is saying the sine of 30 degrees, the cosine of 30 degrees, the tangent of 30 degrees. Now, how about the sine of angle N? So let's switch over to the other side of the triangle here. So if I'm focusing on angle N instead, what would that change about sides in the triangle? What would that change?
The opposite and adjacent spots would just switch.
Opposite and the adjacent. So hypotenuse doesn't change, but now the hypotenuse becomes, now the adjacent becomes the opposite, and the opposite becomes the adjacent. Again, the across from the N is now the opposites across the triangle. All right. Joan, tell me what the sine of angle N is.
The sine of angle N would be √3/2
How do you know?
because it's the opposite over hypotenuse.
Okay. So you looked at the picture and you said opposite over hypotenuse, square root of 3 divided by 2. All right. Do you know another way of getting that? That's fine. You can look at the picture. It's not a problem. But do you see another way of getting that?
It would be the same as the cosine of angle M.
Right. Good. And again, remember that we're actually doing 60 degrees now. So technically we're doing the sine of 60, the cosine of 60, and the tangent of 60. 30 and 60 are complements, right? So that means that these should be the same. So it's square root of 3/2. We can do the same thing here. So if the sine of 30 is 1/2, the cosine of 60 is 1/2. Sarah, can you tell me what the tangent of 60 should be, or the tangent of angle N?
I got 3/√3.
3/√3? Okay.
Yeah.
Why?
So I just looked at the reciprocal of the tangent for angle M.
So these have to be reciprocals. So when you flip that over, if you get 3/√3, does that need to be simplified, or is it okay as it is?
Are you asking me again?
Will that need to
Yes, it should be simplified.
It's got a radical on the bottom, right? Let's pause.
Yeah.
So could you simplify that and get the right answer? Yes. But let's pause for a second. Instead of flipping this over, what would be easier to flip over?
One over √3.
1/√3. If we take the unsimplified form back here and flip that over, it's square root of 3/1, or just square root of 3. So it's okay to do the reciprocal of the value that you found before. It's just going to require some simplifying. Okay, so the tangent of N is opposite over adjacent. If you look at the picture, you can get opposite is square root of 3, adjacent is 1. So there you would also get square root of 3/1. All right, now we're going to jump to the calculator. You need to have a handheld that you can use on your homework today, during class, and then review in the test. You want to be using the same calculator every time, because then you get comfortable with it and you know how to input things into the calculator. So if you don't have one with you right now, you can use a calculator app, but again, I would strongly recommend that you have a calculator that you're using now to get you used to it for the test. Okay, first of all, if you have a graphing calculator, there will be a mode button. your menu will look different than mine because I'm using an app here, but there will be, when you hit the mode button, there will be a list of options. You want to make sure, see down here where I'm toggling, you want to make sure that your calculator is set to degrees. So that's what needs to be highlighted / darkened. Okay, you want to make sure you're in degrees. If you're using a scientific calculator, there's a button most likely that says DEG, or there might be a DRG. There are different ways of measuring angles. Degrees and radians are the two common ways we use in math. Degrees you're familiar with out of 360. Radians is a different way of measuring. So it would be like if you measured in inches versus centimeters. Okay, so you need to make sure your calculator is expecting the value that you're putting in, so it understands that you're putting in a degree, and it's going to spit out the answer that corresponds to a degree measure. So if you have one that says DRG, you might need to like hit it multiple times, but on a scientific calculator, typically in your display someplace, it might say DEG or it might say D if you have it set into degrees correctly. Okay, if you cannot figure it out until you see me, that's okay. I can help you, try to figure out what's wrong, like how to reset modes. But the sooner you can get that figured out, the better, because again, I would like you to use a calculator that you're comfortable with for the test. Okay, sine of 30 degrees. Literally just hit, there will be sine, cosine, and tangent buttons. Sometimes also on a scientific calculator, the menu might look different. Like you might have to hit like a second function to get the sine, or you might have to hit like a trig button that scrolls through sine, cosine, tangent. So depending on the calculator, there's not like just one way it always looks. But on a graphing calculator, it will always look like sine, cosine, and tangent. So if I do the sine of 30, you really don't have to close off the parentheses, but you can if you want. That's exactly 1/2. It's exactly 0.5. Okay, and it says round to the 4 decimal places if necessary. Well, that's exactly 0.5. Cosine 30. Sorry, I hit the wrong button. Cosine 30. Okay, so rounded to 4 decimal places, that would be approximately, I know that says equal there. I'm going to turn them to approximately because I want to make it clear that I'm rounding. 0.8660. Okay, it's going to keep going, but I'm telling you to round to 4 decimal places. Tangent of 30. Approximately, again, I'm rounding, 0.5774.
I have a question.
Yes.
Do you want these in decimals, or can they be in fractions too?
They should be in decimals because on this problem, it's asking you to round to 4 decimal places.
Okay.
There's something special about this problem, why it might give you fractions. But yeah, that's a good question too. On a scientific calculator, when you hit cosine 30, if you're getting a fraction answer, you need to change that mode. That's like math print. I don't even know what they call it, but where it gives the answer in fractions versus giving it in decimals. So if I'm asking for a decimal value, you're going to need to switch that setting to be in decimals. Okay, if I hit the sine of 60, I'm getting 0.8660. Why is that not surprising?
Because the sine of 60 and the cosine of 30 are equal.
The same thing as the cosine of 30, right? So that is what it should be. So if I'm confident that I did sine of 30 correctly, then that means that the cosine of 60 should be 1/2. And again, that's an exact value. Oh, sorry, 0.5. That's an exact value.
Luke, do you not have class?
Okay, for a tangent. So I'm going to go ahead and do tangent of 60. And round it to 4 decimal places, that would be about 1.7321. about 1.7321. Okay. Now, if you don't know that there's a reciprocal button, let's say you did the tangent of 30 and you remember that the tangent of 60 should be the reciprocal. So those are equal, these are reciprocals. There's a reciprocal button down here. It says x to the negative 1. Sometimes on a calculator, it might say 1 over x like that. You can do second function, sorry, I don't mean second function. You can do just hit x to the negative 1 and it'll flip over your answer. See how that's the same thing as the tangent of 60. So you can either type in the tangent of 60 or you can just take the tangent of 30 and do the reciprocal of it, and they should be the same value. Now I want you to notice the values that we got here. And this is what Sam asked me about. Do I want decimals or fractions? Because 30, 60, 90s, and this would also work on a 45, 45, 90, because they're special right triangles and we know those ratios, you are able to give a fraction answer as well, like in radicals, as well as a decimal answer. If I typed in square root of 3 over 2 into the calculator, okay, look at these two tables. If I type in square root of 3 divided by 2 in the calculator, approximately what value will I get? If I do the square root of 3, I'm going to be out of that root there, divided by 2. What's that going to be? Square root of 3 divided by 2. What should that be based on this table?
0.8660.
0.8660. Okay, so we have the decimal form of it and we have the fraction form of it. Okay, see how it's the same thing. All right, we're going to set up, I'm going to go a little bit fast. We're running a little short on time here. And I want to make sure you are understanding how to set this up for the homework. In this picture, we have a 36-degree angle. Okay, I'm going to label the sides hypotenuse, opposite, and adjacent in relation to the 36. Now, one of those numbers is simple. The z value, you could do that without even knowing any trig, right? Z is just going to be, I'm not going to worry about adding it to 180. I'm going to add it to 90 because remember, this is 90 degrees. So those two are complementary. So I'm just going to do 90 minus 36. And I got 54 degrees. Now, I'm really not going to use the 54 degrees in solving the rest of the problem because I'm going to use the numbers that were given just in case I made a mistake like subtracting or something. I don't want to throw off other answers. So I need to use the 36 degrees and the 8 that were given in the problem. Now, if I wanted to find x in relation to 36 degrees, x is opposite and 8 is hypotenuse. Opposite and hypotenuse. Let me write the SOHCAHTOA again. Opposite and hypotenuse is sine. Okay, so I'm going to say the sine of 36 degrees is opposite over hypotenuse. Now, the opposite value is x. The hypotenuse value is 8. You have to train your brain to see sine of 36 as a number. I know when you first look at it, you're like seeing the letters and it seems weird, but that's a number, it's a ratio. So if I wanted to solve for x, I'm going to multiply both sides by 8 because I want to get rid of that 8. Oops. Okay, so it's going to divide over there, and that's what you're typing into the calculator. 8 sine of 36. Rounding to the nearest 10th, that would give us approximately 4.7. Okay, make sure you're rounding correctly. I want to see an equation and then what you solved, to get that answer. Now, if I was doing y, so instead of finding x, I now want an equation that involves y. So I'm going to use the 36, the y, and the 8. In relation to 36, I'm using the adjacent hypotenuse. So I'm going to do the cosine of 36. The adjacent is y, the hypotenuse is 8. It's going to be the same thing we did up above. Multiply both sides by 8. Divide that out. You can put parentheses there if you want to, but it doesn't have to be there. If you put the 8 after the 36 degrees, you do need to put parentheses. But if you write in the front, you don't have to do that. 8 cosine 36. Y is approximately, to the nearest tenth, 6.5. Now, one more thing. On a problem like this one, let's say that you're writing an equation that involves 38, 14, and x. This time, when you make your equation, it would be the tangent, because tangent's opposite over adjacent. The tangent of 38 degrees would be the opposite, which is 14, over the adjacent, which is x. You have a variable in the denominator this time, but you're going to do the same thing. You're going to multiply by the denominator because you're trying to get the denominator like cleared out, right? That's going to cancel over there. Now, think about this as an equation. It's x tangent 38 equals 14. So we can divide both, again, remember tangent 38 is a number. So when you divide both sides by tangent 38, that's what you type in the calculator. Okay, x is 14 divided by tangent 38. So if you do 14 divided by tangent 38, that's your value. X is approximately 17.9 right of the tens. Okay, if you're not getting the same values as I am, then you've got some setting wrong, or you're typing something in incorrectly. So again, if you need to use a calculator app on your iPad, then do that if that's going to be helpful for doing the homework tonight. But you do need to have a calculator handheld that you know how to use, that you're comfortable with for taking the test.